Welcome back. Previously, we implemented a transaction pool component that has the ability to view the transactions that are currently in the pool. However, this currently isn't configured yet to pick up any new transactions that have been added in the pool within the network. To address this, we can implement polling logic in the component. Essentially, the component will make a new fetch for the transaction pool map at the set interval, giving it the chance to find any new transactions from the pool. First up, head back to the transaction pool.js code, and at the top of the file, let's declare a constant before the class called poll interval in all caps, since this is going to be a global value. We're also going to have an MS extension on this, since this is going to be valued in milliseconds. Our interval is going to be 10 seconds for polling for the new transaction pool code. So that value is 10,000, since 10,000 milliseconds is equal to 10 seconds. And now we can set an interval for the fetch of the transaction pool map to happen at this poll interval. To run JavaScript code at an interval, well, we have the setInterval function. This takes a callback for some code to run as the first parameter, and this callback is going to call this.fetch transaction pool map over again. All right. And as the second parameter, we provide the interval, which in this case is our poll interval ms value. All right, very nice. Now this should do the job of refetching the transaction pool map every 10 seconds. So let's see this in action. Save the file, and in the command line, make sure the application is going with an npm run dev command. Then visit localhost 3000 on the front end. You're going to want to go to the transaction pool. Right now the page is empty. That's fine because the overall app has restarted. The thing to look for is in the browser developer tools, go to the network tab. And you're going to see that around every 10 seconds, there's going to be a new fetch request for the transaction pool map done. So there it is, a get request for transaction pool map. And if we wait around again for another 10 seconds, we're going to see transaction pool map as well. And there it was. Cool. So regular requests are being made to fetch the transaction pool map data. So this means that we should be able to pick up transactions submitted by peers in the blockchain network. Let's start up a peer application and then conduct a transaction. In the command line, let's open up a second tab and then fire npm run dev-peer. Cool. You're going to want to track where the application started. So right up at the top, it started at localhost 3382 for me, but yours is going to be at localhost 3xxx, and you're going to want to visit that in the browser. Now, the convenient thing about this is that since we have the built HTML, JS, and CSS right in the project, every peer should have its own Express server to serve up its relative application. So at localhost 3382, I can also visit its own version of the front end. Cool. Now we want to conduct a transaction. The recipient can be foo, and let's do a value of 30. But if you open up the console, you're going to find that we have an error. And this error is related to fetching from the wrong origin, and we're being blocked by the CORS policy. Now, this error is actually valid because our peer is hosted at a different address than the localhost 3000 backend. So normally when we're starting up the application, the front end is hosted at localhost 3000, which has the same origin as the localhost 3000 API request. But in this case, we're at a dev peer, and it's a security concern as browsers implement a cross-origin check to make sure that your application hasn't been hacked and messed with to make requests to an unknown address. So the origin of the front end now is localhost 3xxx, which is different than localhost 3000. But we can address this in our front end code. Rather than hard coding localhost 3000 for every request, we can have this app make a request to the origin automatically using some code. So back in the application, rather than the hard-coded HTTP localhost 3000, instead we can use the document.location object, which has an origin field, which will return HTTP localhost 3000. And we want to do this for every single request. So notice that we turn this into a template string with backticks, and then the $ curly brace syntax to interpolate document location origin into the request. But again, we want this to be for every single request. So go ahead and search up localhost 3000 in the application. In the app.js file, we need to make the same change. So let's do document.location.origin for the wallet info request. And then the endpoint is still /API/wallet info. Feel free to copy this first part that we need to update for the other blocks request. So let's overwrite that. So now it's going to the document location origin API blocks. Likewise, let's do the same thing for the conduct transaction request. So now it's going to document location origin API transact overall. Cool. So now that we have this updated, that covers all fetches using the hard-coded localhost 3000 value. Let's go ahead and try this one more time. So we're going to need to find the new peer address since we saved the file, which starts up the overall application over again. And this time mine is at 3198. You're going to have to find the one of yours as well. Now in the peer, I can go to conduct transaction at 3198. And now when I make the recipient foo and the value 15, I can submit, and this should say success. And the transaction pool here contains that new data. Now in the main localhost 3000 transaction pool, because of the polling logic, in due time, it should pick up the new transaction. And indeed, there it is. Cool. So the new transactions are appearing for every single peer in the overall blockchain network. Very nice. Before we move on though, there's one nasty error with how we implemented our logic. It's a bad practice in JavaScript to set an interval of code without ever clearing that interval. Otherwise, the interval could silently continue in the background, hog the JavaScript engine's resources as it continues to make fetches and slows down the overall application. So this ill side effect is actually present in our application and plaguing the app. To see for yourself, notice that we're making these transaction requests, and it's fine that we're doing that for the pool map within the transaction pool component. But then if you navigate back home and you keep an eye on the overall request tab, you're going to find that eventually a transaction pool map request is still going to be made. So we're not even in the transaction pool component anymore. So why is our component, or rather why is our app still concerned about making transaction pool map requests? It shouldn't be doing this. We need to make sure that this interval is cleared if we leave the transaction pool. So in the transaction pool.js code, what we want to do is we want to add a new component will unmount lifecycle hook. And this will allow us to run code as soon as the component is left from the HTML and removed from the document. In here, we want to call clear interval. And this allows us to remove an interval of code that should be called from a set interval call by referring to a reference to that set interval itself. Now we don't have a reference, but we can set a fetch pool map interval reference to the result of the set interval function, which now allows us to look at the set interval itself, which we can now call this.fetch pool map interval in our clear interval code. All right, so this should attach the interval itself to the actual component, and when it's left, the fetch pool map interval will be cleared. Let's go ahead and see if this update has made any changes. So refresh the application, go to the transaction pool. Because we saved the overall app and our application restarted, the transaction data should be removed, but it's fine to be empty. What we're concerned is, or rather what we're looking for, is that the transaction pool map is no longer being requested for, as long as we go to the home component. So overall, we have 15 requests in here. One is for the favicon.ico file, which is for this little icon in the browser. We don't have that, but definitely add that for a production version of the code. We see a wallet info request, but it's been some time now, and we're not getting any new transaction pool map requests. So this is very nice to see. No longer are we seeing transaction pool map and the fetch over and over again. Okay, the only way to get these transaction pool map requests back is to actually visit the transaction pool map component itself. Overall, that wraps up the polling logic to make sure that this transaction pool always has the most up-to-date and current data possible. Finally, now that the user can view the transactions in the pool, the last piece of this initial front end is to give the user a way to mine these transactions. After all, these transactions won't improve anyone's balance until they're actually recorded in the blockchain history. Let's do that next.